So we are talking about volumes of prisms and cylinders. Cylinders kind of fall in the same category as prisms, and I'll explain why. And you have a quick and easy formula for the volume of a rectangular prism, but I'm going to kind of skip over this. You can use it, but I want to look at a more general formula for any kind of prism that applies to the rectangular base prism, but applies to other things as well. So here it is. It should just say all prisms, not all other. Okay. So all prisms follow this formula of the volume is equal to the area of its base times the height between the bases. Okay. And the confusing part of this is just trying to figure out, all right, here's my object. What's the base? Okay. And because the base will not always be the bottom of your figure. Okay. It's just like when I'm thinking about my height, if you measure your height, right now we think of the base as your feet, right? And you stand up and your height is perpendicular to the base of your feet, right? But if I'm laying down and somebody wants to measure my height, they're going to measure horizontally, right? Because I'm not positioned vertically, right? And so these shapes may not be positioned the way you'd like them to be positioned, but you still have to know what's their height, what's their base. So a couple things here. You want to know that the height is always perpendicular to the base, okay? So the height of the prism is always perpendicular to the base of the prism. And the base of your prism is not a length. The base is a two-dimensional shape. And that's why we're talking about the area. So the base is 2D. It could be a triangle, it could be a square, it could be a moon. Okay, it could be any 2D shape. So take a look at number 6. Okay, first you gotta visualize this as a three-dimensional shape. But think about how prisms are created. Okay, a prism is created. We start with the base, and you get a bunch of replicas, and you stack those on top of each other to create your shape. So let's just think. If I made this this is what it's sitting on, right? Could that be the base? No, because if that was my base, this whole shape would be created by I get a whole bunch of congruent, looks like a square or rectangular shape of that size, and I'd stack them on top of each other, and it wouldn't make this because you could tell the top part's bigger than the bottom part. They're definitely not congruent. So I know that's not my base. Anybody see what the base would have to be of this thing? Okay, so you're thinking this up here? Okay, so if that's my base, so think of that with this, if I got a whole bunch of those rectangles and stack them on top of each other, would I get this whole figure? Still wouldn't, because this is smaller, right? So that wouldn't work either. Kateri? Let's see. So you're thinking this right in here? Okay, so if I got a bunch of trapezoids and squish them together, would it create that shape? Yes. So now we know we found the right shape. So because if you look opposite that side, and I'll outline it, this piece right here. One test is to ask, well, is that congruent to the front side? Yeah, Those are both congruent. It is hard to visualize because it's it's a three-dimensional drawing on a two-dimensional paper. So you have to have a little visualization here. But those would be identify your base. You have to identify your base. So we need to find the area of the base, and then the height of our prism is always perpendicular to the base. So can you see what the height would be of the prism? Okay, careful. The 17.9 is perpendicular to this part of the prism, right? But that 17.9 is part of my prism. Sorry, part of my trapezoid. Is that the right name? Yeah, part of my trapezoid. So the height of my prism is not part of my base. This green part is my base. So what number is not part of that? The 25. So that would be your height. Although it doesn't look like a height, right? It's not positioned in the correct way. So this is the height, right? And then the green part is our base. So our volume is going to equal the area of the trapezoid times the height, which is 25. Right. Now, you want to know the formula for the area of a trapezoid. You got to have that memorized. If you don't know it, it's in the front of your packet, but you want to have that memorized, or at least know how to find that area. So a trapezoid now. Okay, so I'm going to just draw that trapezoid. Okay, a trapezoid has bases too. Okay, so I'm using that word base again to mean something different. So the trapezoid has two bases that are parallel, not the same length. And from our picture, can we tell what those lengths are? 14 and 36. And our trapezoid has a height as well, which is not the height of our prism. Okay, you got to distinguish them. Our trapezoid has a height of what? 17.9. And so the area of our trapezoid is 1/2 the sum of the bases, 36 plus 14, times its height, 17.9. That's the area of our trapezoid. And then don't forget to bring down the 25. And then this is going to be the volume that we want. Okay. Carefully crunch that number in your calculator. And what are we getting? For the whole volume, yeah. 11,187.5 and meters cubed, or cubic meters. I have a second to verify that. Anybody else try it separately? And you got the same thing? Okay. So it's really key to find the base correctly, because if we've identified the base wrongly, we would get a wrong answer, right? So what I want you to do in number 1, 2, 3, and 4, and 5, I want you to shade in just slightly with your pencil what you think the base is of each of those shapes. 1 through 5. Shade in with your pencil what you think the base is. Okay, so as we said with number 1, 2, and 3, these are rectangular prisms, so any side can act as a base, and it will work. And so I can make the bottom the base, and that would be fine. Or you can make the side a base, doesn't matter. Like on number 2, it doesn't matter, it's a rectangular prism, so maybe I'll make this part my base. And on 3, maybe I'll make this part my base. It really doesn't matter. Okay. In number 1, though, if I highlighted my base. What would my height be? Okay, I'm going to circle my height. Okay, that would be my height. If that's the base. Now, if you made something else your base, then something else would be your height, right? And with rectangular prisms, you have the freedom to do that. Number 2, what would my height be? 14 would be my height of the prism. And number 3, what would my height be? 12. It's perpendicular to the highlighted part, so this would be my height. Okay. Now, when you get to 4 and 5, it matters what you chose as a base. These are no longer rectangular prisms. Can somebody share what they highlighted as a base for number 4? Yeah, Wyatt. This piece right here. You guys agree? Good. Because you could stack that up. Did you have a question on 4? You want to share on 5? Or what was your hand up for? You sure? Okay. So my next question though is what's the height of number 4? Now there's only one number that you could pick for a height. 5 would be the height. Okay. On number 5, what's the base? Right here. You guys agree? Yes. That if you stack a bunch of those right next to each other, it would create that shape. And then what would our height be? 16. Okay. Yes. So for the base, you could choose there's a you could choose either side of the base, right? So yeah, on the number 5, you could choose the back part. Same as number 4. If you view that as the top, you could choose the bottom, right? Okay, so I want you guys to find the volume of number 7. Find the volume of number 7. All right, you too. So here our base is a triangle, the right triangle in particular, and we need to find a length or a side length of that triangle. So we use Pythagorean theorem. It's 16.5, and the area of that triangle is 231 square kilometers. So then the volume is you multiply that with the height of our prism, which is 31. You get 7161 cubic kilometers. Okay. How are you doing with that? Okay. So cylinders. Cylinders are just like prisms, except the base is a circle, right? So it follows the same formula. We could still say the volume is B times H, where our base is a circle, and so B would be pi r squared, and the height would be perpendicular to that circle. Okay. I want you guys to try number 11. So on 11, we have a triangular base prism, and then this hole is drilled through it. So that hole is like a cylinder, right? And that hole has a 2 centimeter diameter. And so in order to find the volume of this, whatever's left over here, we're going to have to find the volume of the whole prism minus the volume of that hole drilled through the middle. Okay, so you have to find two volumes and then subtract them. Okay. For the prism, the base is that triangle. It's a right triangle, so the base, it's 1/2 5 times 5 gives us the area of that triangle, and 14 is the height of our prism. The cylinder has a radius of 1 because the diameter is 2. So pi times 1 squared is the area of that circle, with 14 being its height. And so you can end up getting about 131 cubic centimeters here. Okay. So your homework is going to be the next two sheets. So you have this page, which is page what, 13? 13 and page 14. Okay. So what I'd like you to do on each of these, yes, show work. I don't want to see just the answer that you typed a bunch of numbers into your calculator and got an answer. I want you to shade each of the bases on each of these, so I know what base you're using. Maybe circle the height like we did together, and then get these answers. Okay.